This video is about my learnings and introduction to hyperbolic geometry. So I'll start with a little bit of history. It's a long history that goes back to Euclid of Alexandria. So he wrote this famous book, The Elements, that's typically presented as the most influential textbook of mathematics ever written and effectively remained kind of the reference for geometry and mathematics for over 2,000 years. Although it's very old, the approach seems very modern, and the idea is to construct all of geometry and even all of mathematics on solid foundations with the following rules of inference of logic, based on a very few sets of fundamental truths called postulates or axioms. Here, I just include a photo of a manuscript of the Elements, where you can see the Pythagorean theorem. This is a 19th century manuscript. What are those 5 fundamental truths of postulates or axioms? Let me go over them quickly. There exists a line through any 2 points. Here, it's implied that it's a straight line and we're talking about a plane. So the Euclidean plane, any points can be joined by a line. Any line can be extended indefinitely, so lines are infinite. One can always draw a unique circle given a center and a radius. All right triangles are congruent, which means they look the same. And finally, there is this controversial 5th axiom that sounds a little more complicated. So let me just show you a picture instead of reading it. Where in this configuration, we're talking about 2 lines and prime, and they fall on the 3rd line, here making angles alpha and beta. And the 5th postulate says that if these angles are less than right angles, as on this picture, then these 2 lines and prime must intersect. So you might wonder why this controversial sounds. It's very reasonable, as this picture shows that line prime intersects on the right hand side here, but this seems like it's a little too complicated to be a postulate, which should be one of the most basic truths. So for a long time, mathematicians tried to derive these axioms from the other form, and they were unsuccessful for almost over 2,000 years. Finally, the 19th century mathematicians created or discovered the geometry, where the first axiom are true, but not the 5th. And this is hyperbolic geometry. And we have some of the most famous mathematicians here whose names are attached to this new geometry. So I want to show to you what is it, and there is different models for hyperbolic geometry. But one of the reasons it took so long for mathematicians to discover it, that it, unlike spherical geometry, it's hard to represent the hyperbolic plane. This is one of the possible representation of this disc called the Poincare disc. It's the inside of the circle, and what we call straight lines is hyperbolic geometry, would be this arc that you see that are actually arcs of circles, Euclidean circles that are orthogonal to the boundary of the disc, and well, maybe it's kind of clear for instance that the first axiom is satisfied. So if I have 2 points A and B, I can draw a unique line, straight line between quotes, like this now. What's not accurate in this model is the measurement of distance. So I would have to tell you how you measure hyperbolic distance between 2 points, but it's very different from the Euclidean measurement. And in particular, when you approach the boundary of this disc, the hyperbolic distance actually explodes. So this hyperbolic disc looks finite. Thank you for taking your time for watching my video. I hope that you learn new about hyperbolic geometry.